Bismillahirrahmanirrahim. This lecture for Automotive Electronics EE202. And we are currently going through our chapter number 8, that is the automotive wiring and wiring repair. And so far we have done the American wire gauge system, the ground wires, the cable wires, the jumper wires, and the fuses. Okay, so last time I think we finished at this slide, at slide number 8. ऐसा ही है?
Yes, sir.
Okay, so today we will start. We will resume from this slide. A recap for the fuses. Fuses are our protective devices, and the construction fuses should be used in every circuit to protect the wiring from overheating and damage caused by excessive current flow as a result of a short circuit or other malfunction. The symbol for a fuse is a wavy line between 2 points, and this diagram shows the symbolic representation of a fuse. A fuse is constructed of a fine tin conductor inside a glass, plastic, or ceramic housing. The tin is designed to melt and open circuit if excessive current flows through the fuse. Each fuse is rated according to its maximum current carrying capacity. Many fuses are used to protect more than one circuit of the automobile. Okay, so let us look at figure 8.3. This is the figure 8.3. This figure shows a fuse panel, a, a device which is called a fuse panel. In the panel, the fuse panel is a collection of many fuses that are used inside the automobile. These fuses are protecting one special circuit. So in this diagram, we see a fuse panel, and there are many fuses found within this fuse panel. For example, let us look at fuse 10. Each fuse is numbered. It is of 5 ampere and it protects instrument illuminating lamps, headlamps on wiring and electronic AC. So this is a mixture. It will protect a instrument that illuminates the lamp. Now another fuse, circuit breaker of power windows, roof and fuel cap release. Another fuse, fuse white 25 ampere, heater, AC radio capacitor and deck LED. Then radio capacitors. So these are a collection of fuses that are protecting particular circuits. For example, circuits of power windows, circuits of lamps, circuits of headlamps over here, or circuits of windshield wipers, or circuits of seat belt, light and buzzer, and many other fuses. Power antenna, the air conditioners, the lighters, the electronics, the converter clutch that are not visible to the driver but they are used within the engine, and so on. Right, next. Now we come to
Sir.
the next fuse rating. Fuses are used to protect the wiring and components in the circuit from damage if an excessive amount of current flows. The fuse rating is normally 20% higher than the normal current in the circuit. So इसका क्या मतलब है? Let us understand the meaning of the fuse rating is normally 20% higher than normal current in the circuit. So let us draw a circuit, very simple circuit. We have a circuit like this, and here we have the fuse. We will use a fuse in series. Then we have a switch, and then let us say that we have a light lamp, right? And the battery voltage is 12 volt, and then this is a switch. It can be our on off switch, and then we have a light bulb. The resistance of the light bulb, we set the resistance R equal to, let us suppose, 12 ohms. ठीक है? So now under normal condition, what will be the value of current? When we close this switch, what will be the current flowing normally in this circuit?
1 ampere.
1 ampere. So the current will be a 1 ampere. Now let us decide the value of the fuse. How much fuse, how much should be, what should be the rating of the fuse?
So 0.2.
1.2 amperes.
So our fuse should have a capacity of 1.2 ampere. Thus this fuse rating should be 1.2 ampere.
सर ये 1.2 कैसे?
1.2 इस वजह से कि नॉर्मल करंट आपका है 1 एम्पेयर, और ये जो लाइन है लिखा हुआ है कि द फ्यूज रेटिंग इज नॉर्मली अबाउट 20% हायर देन नॉर्मल करंट. तो 1 एम्पेयर का 20% हायर क्या होगा?
Yes, 1.2.
तो
जी सर ठीक
1.2.
है.
तो कितने फ्यूज, कितनी कैपेसिटी का फ्यूज यूज करें? 1.2 एम्पेयर का फ्यूज यूज करें.
सर अगर हायर कैपेसिटी वाला यूज करने तो
Okay. Now if we by chance, if we don't use 1.2 and let's say we use a fuse of 2 ampere, आप 2 एम्पेयर का फ्यूज यूज कर लेते हैं. नाउ व्हाट विल हैपन?
सर ये ज़्यादा पोटेंशियल पे करंट पे सर फ्यूज़ नहीं होगा तो आगे जो चीज़ें हैं अप्लाइंसेस हैं वो शॉर्ट होकर ख़राब हो जाएंगी.
So this means that if we use a fuse of 2 ampere, then this fuse will allow 2 amperes to pass normally. However, our load is our load is of 1 ampere. So this means at some fault, we are allowing 2 amperes to pass through the wire, through the bulb also. So this may damage the wiring, and it may also damage the load itself. So to protect the wiring and to protect the load, we should use a fuse which is just 20% higher than its normal value. Up now in chart number 8.5, in table 8.5 or chart 8.5, we see the normal current in circuit and the fuse used within the same circuit. For example, in the first entry, there is 7.5 ampere. This is the 7.5 ampere is the current which normally flows through a circuit. Maybe this circuit consists of light bulbs, the headlights, and the fuse that we are using is 10 ampere. Again, this 10 ampere is only 20% of 7.5 amperes. Likewise are the remaining entries, that if the normal current is 16 ampere, then a fuse of 20 ampere should be used, and if a normal current is of 24 ampere, then a fuse of 30 ampere should be used over here. And then in figure 8.4, we see a blade type fuse. This is a very commonly used fuse, and these two terminals, these are of blade, and this is the reason why it is called a blade type fuse. So these green terminals, they are our terminals that make connection, whereas this red is transparent plastic body, and the actual fuse, which is made up of tin material, tin. We have the tin over inside the plastic fuse. So here, this is the tin material. This is the fuse itself. So when, and this value is of 20 ampere. Normally the fuse rating is written on top of the fuse. So when a current of 20 amperes passes through this fuse, the tin material, it will melt away. When this tin material it melts, it converts the circuit into open circuit. And when
सर
that, हाँ जी,
सर ये यहाँ पे जो वैल्यू लिखी हुई है ना 7.5 एम्पेयर, उसके लिए उसने फ्यूज रेटिंग यूज़ की है 10 एम्पेयर। तो 7.5 का जो 20% होता है सर, वो 1.5 होता है। तो ये 9 एम्पेयर का इसे यूज़ नहीं करना चाहिए था फ्यूज।
आपकी बात सही है, लेकिन हर वैल्यू के हर वैल्यू के फ्यूज हर एग्जैक्ट वैल्यू के फ्यूज अवेलेबल नहीं है। तो उसने फिर क्या किया कि नेक्स्ट मोस्ट क्लोजेस्ट वैल्यू वो यूज कर रहे हैं। दैट इज, आपके अगर आप लोड लगाते हैं और वो लेट्स से 2 एम्पेयर है, लेकिन 2 एम्पेयर का मतलब क्या होगा कि 2 एम्पेयर के लिए फ्यूज आप यूज करेंगे 2.4 के लिए, 2.4 एम्पेयर का। तो 2.4 का एग्जैक्ट फ्यूज अवेलेबल होना 100% पॉसिबल नहीं है। हो भी सकता है और नहीं भी हो सकता। सो स्टैंडर्ड वैल्यूज नहीं है। सो इफ इट इज अवेलेबल देन वी शुड यूज इट, इफ इट इज नॉट अवेलेबल then we will use the available one, which is the closest.
जी सर, ठीक है, थैंक यू।
Okay, अब इसके बाद yes, so this tin fuse, so this tin material will melt when we have 20 ampere or larger than 20 ampere flowing through this fuse, and it will convert the circuit into open circuit. अब यहाँ पे लिखा हुआ है this small blue colored area, fuse test point. We have an opportunity to test the fuse also. We, as the user can test the fuse by using a test point circuit, that it will be a small light. It will check if the fuse is healthy, then current will pass. If the fuse is destroyed, it is blown away, then it will be an open circuit and no light will be provided. So we can test our fuse from this point, from these 2 points. Now we come to the next slide. In this slide, we have the various types of fuses and their diagrams, their most popular available fuses and their diagrams. So first we have the blade fuse. Figure 8.5 shows three sizes of blade type fuses. Then there are the mini fuses and maxi fuses. Mini fuses and maxi fuses are determined based upon their size. The mini one on the left, the standard on the middle, and the maxi one on the right. These maxi one are the maximum available in size. So the mini fuse, they will carry very small current. Standard fuses, they carry a normal size current, whereas maximum fuses, they will carry, as the name suggests, they will carry large amount of currents. Right. Then comes the Pacific fuse element, and here is the diagram of the fuse element. Testing fuses. These are fuses that will be used for testing purposes. Then we have circuit breakers. They can be used multiple times. Fuse Normal fuses, they are one time operational. Then there are PTC circuit protectors, fusible links, and mega fuses. So this slide demonstrates the types of fuses available. Now, fuses are color coded. Fuses are color coded. That means that colors, they define the values of the current handling capacity of a fuse. Fuses, for example, red color determines a 10 ampere fuse, blue color determines a 15 ampere fuse, yellow color determines a 20 ampere fuse, and 30 ampere fuse is determined by green colors. And then the figure on the right displays the fuse panel. It is again a collection of fuse terminals, and the status of the fuse can be determined by looking at the fuse terminal. और यहाँ पे in the figure on the left shows 2 points, 1 point over here and 1 point over here. This 2 points determines that these are the 2 points through which we can check without removing the health of the fuse.